Rhoman Aerospace Corporation, Thomas Youmans.
Cool. Awesome. Hey, how's it going? Tom Youmans with Rhoman Aerospace. Really glad to be here today. So Rhoman Aerospace is doing some groundbreaking stuff with vision autonomy, and our defense and commercial customers are super excited about this. So we've been in the autonomous drone space since 2019, and in this time we've started to see this one major problem across defense and commercial drones. Drones don't work without GPS. You see, they're kind of like us driving through a new city we've never been to before with Google Maps open. If we lose GPS, we're totally lost. But for drones, if they lose GPS, not only do they get lost, but they crash. This is why the Ukraine loses thousands of drones every month, because Russia can jam GPS. And this means that there are billions of dollars of US military drones that will not work on the future battlefield because that battlefield is GPS denied. But what if drones could work without GPS? What if drones could see and navigate like people? What if drones could navigate in a direction using the features and objects in their surroundings? So right now, they cannot until they download our solution. It's a software download to existing drones that uses their existing cameras to let drones see and navigate like people so they don't crash if they lose GPS. So this is a really tough problem, and this is a big deal. So we actually proposed our solution to the Pentagon, and they're paying us over $250,000 to put our technology onto the drones. But this is only the start. We're also talking to the defense drone space, and they're excited about licensing our technology because they know that drones have to work without GPS, and they want to provide these drones to their military buyers. And beyond that, we're also talking to commercial drone companies, because commercial drone companies know that commercial drones cannot scale out when something as simple as flying between two buildings, having GPS be knocked out for a second, can make your drone either crash or fly off who knows where. Now, there's one other stakeholder that we should talk about here. The FAA, the Federal Aviation Administration, regulates drones and airplanes in the airspace, and they need to make sure that drones and airplanes stay in the sky. So they need drones to work all the time, and they need drones to have backup safety features. Our solution keeps the drone in the air no matter what and provides the backup safety features the FAA wants to see on drones to approve them to deploy commercially. Now, this is a multi-billion-dollar market. The last mile delivery space, which is perfect for addressing with autonomous drone delivery, is estimated at $90 billion. And people are putting their money where their mouth is. Amazon has invested almost $2 billion in their drone delivery program. And Zipline, a medical drone delivery company, has recently closed a $400 million round of funding. Our vision is to be the vision system that has to go on every drone commercially so that it can scale out across our future autonomous skies. Now, we've got a great team of machine vision and aerospace PhDs building and selling our core technology. So now we're raising our seed round so that we can productize this technology and enable Rhoman and the commercial drone market to get to scale. Thank you. Love to answer questions.
All right, who's first?
Matt?
Yeah.
I'll go. Oh,
Yeah.
I'm curious what the regulatory pathway is. It as a supplemental type certificate, or what other kind of FAA approval would you need to show that this works?
Yeah, so the sales version of this is you can take your drone, go to the FAA, go through all the regulatory channels, do all the tests, and then eventually do your own operations beyond line of sight. Or you download our solution, connect to our commercial cloud subscription, and you can get flying immediately. That's the sales answer. On the regulatory front, autonomous flights at scale for drones flying beyond line of sight with many drones managed by one person are definitely a year to multiple years away. So deploying our technology on drones that are used for some commercial purposes, and we'll probably start with Part 107 services and just use this as a safety mitigation to get those approvals is the first step here. And then making this be a key capability that lets drones go from Part 107 regulation to Part 135 regulation is going to be a really big piece in the value system here. And for people that are not super familiar with the drone type certification, that sounds like you are, a drone that has, if you have Part 107 certification, you're allowed to go fly your drone for money, to commercially use your drone yourself. If you want to carry another person's property or carry another person's property over state lines, you need to get Part 135 certification. That's a much bigger deal. 6 companies have that. A bunch of companies are working on it. And we see this system that can have the drone see the features in its landscape, navigate if GPS gets knocked out, see and avoid other drones in the air as a really, really essential feature to letting commercial drones scale out to fly beyond line of sight for future at-scale operations. Maybe that was more than you asked.
So help me understand, who's your customer? Is it the drone manufacturer?
So usually it's the drone manufacturer. So drone manufacturer, sometimes it's the drone manufacturer, sometimes it's the operator. So let's say you're a drone manufacturer and you're selling drones to Special Operations Command. Special Operations Command is giving us money right now to deploy our technology, to demonstrate it to them. And so they're like, Tom, listen, we want the drones we get to fly without GPS, so we want you to finish your technology and then license it to these other drone companies. So when we buy drones from them, those drones will work without GPS. So in that case, the drone manufacturer is licensing our technology so they can sell a product that their customer wants to pay extra for.
And is it hardware, software, and the mapping? Because obviously for you to fly into Paris and whatever you were showing us there, somebody needs to do the map for the drone to understand that they are in Paris or something, right?
So in the first use case we're deploying right now for Special Operations Command, the drone isn't creating a super, super high fidelity 3D spatial map while it's flying. You're like, all right, I'm out in the field. I think there's a white pickup truck 5 kilometers that way. I have no GPS, but I want the drone to go over there. Drone, 5 kilometers that way, go. So what it's doing is it's seeing visual features in its landscape, tracking those features and recording its position relative to those features while it's flying. These are the visual breadcrumbs the system is creating. So then it sees these visual features and uses them to get itself back to launch no matter what. So in this case, it's creating a really kind of light map of features and objects along its flight route.
To find its way back.
To find its way back. And then on the commercial side, you're going to not experience as much active GPS jamming. But one of the key uses on the commercial side is right now, if a drone suddenly loses GPS, sometimes they'll crash to the ground, sometimes they'll just fly away in random spots. When you're driving your car through a city, you ever see the Google Maps little blue arrow go crazy, you pull out of a parking garage, you drive between buildings, the GPS gets blocked. So on the commercial case, this will let a drone keep on its route, even if GPS gets knocked out for a little bit, and it will also provide the drone the backup safety system so the FAA knows it's able to do this. The last piece of your question was, do you sell to OEMs or to users? Another use case is, let's say there's a drone delivery company like Walmart's drone delivery company, DroneUp, and they're a user of various drones, so they're providing drone delivery services. And because our solution can deploy by software download using the existing cameras on the drone, they can be like, okay, we've gotten all these drones, we worked with all these drone partners, but we want the drone to fly beyond line of sight. Let's get these added safety use cases. Tom, send us your software, we'll put it on all these drones. We're like, okay, that's a nice licensed situation. And then them as the user, they enable other drones to do these operations.
So what's the use case sort of look like? Let's say, what's the proprietariness of kind of the technology that you're doing? For example, there's a lot of guys doing indoor warehouse, right, which is GPS deprived, right, quite a bit. And they're kind of maneuvering with just simply kind of perception sensor, visual perception sensors, right? Not even using LiDAR or anything like that, right? How protectable is your approach, right, kind of to this?
So we have 4 issued patents and multiple pending patents. One of the main differences between the indoor systems, typically they'll be using SLAM systems. SLAM systems will basically, the cameras on the drone track all the pixels that the drone can see all at once, and then track every single pixel while the drone is moving to see how the drone is moved relative to what its cameras are seeing. That gets really data intensive, and there's a lot of information. So when you're inside, you can potentially track this. This kind of shows the drone following these visual breadcrumbs to its logistics drop-off destination back to launch. But so to deploy basically the SLAM systems, because they record so much information, it's tough to do it outside, let alone flying 5 kilometers. So this really scales that back to be detecting certain objects. So we have the patents, which is always a great start. We also have a lot of experience in drone control software and drone control theory. So being able to input capabilities and technology into the weeds of the software stack of the drone is something that it takes a long time to get ramped up on.
How unique does the terrain need to be?
So we're figuring out some more details on that through this current SOCOM R&D effort. Yeah, so in this system you can see there's this little laser pointer on here and now. Yeah. So in this picture here, you can see the system tracking various pixels in the environment. So we run our main system, which is tracking features and objects in the environment while the drone is flying. Then in parallel with that, we're running this, not SLAM, but it's like an AI-based pixel tracking system. So it chooses certain sets of pixels to track. So you have a secondary estimate of your position, purely pixel-wise, combined with the object tracking thing. Then if you run into an area in the flight where there's not a lot of objects, the pixel thing takes over to maintain your heading until you start to latch onto more objects.
And this is a more, I guess maybe not a direct use case question, but just wondering how transferable is your technology or system for non-aerial applications, so underwater mapping, underwater drones?
Yeah, so the system, we see the system in the future. It's basically helping a drone or robotic system visually take in its surroundings and do the right maneuvers in that case. So maybe you're an industrial manufacturing robot and you have to be like, oh man, I see a person over here. I can kind of detect their intent is moving this direction. I better slow down my movement. We see that long term. If you're an underwater robot, it seems like an amazing overlap here, because if you're a drone that's underwater going through the ocean, you got the ocean floor, you're going in the air just like you're flying. So the algorithms would make a whole lot of sense. The problem is that the sensors to see the ocean floor through the ocean water, that's super intense and tough to do because the ocean water gets so thick, it would take a ton of power. So the algorithms would work, the system could be deployed there. That's not our current focus, but we like the idea of that.
Can you talk a bit about your partnerships and potential partnerships, and what level of co-development is necessary for each deployment?
Yeah, so at first we thought all of our customers want a software download so we can snap our fingers and they can get a software download onto their drone and everything's perfect. And then for smaller drones, that definitely makes the most sense.
When you say customer, you mean the consumer?
Customer, I
Or
mean the drone company.
Oh.
Our customers being
Yeah.
the drone company that want their drones to fly without GPS.
Okay.
So at first we thought everyone would want a software download. And then we started talking to some drone companies, and they're like, we like the idea of that, but let's get a few versions flying perfectly before we fully integrate. So let's just get ourselves a nice little hardware box that has a few cameras, has a nice NVIDIA chip. We can put that onto the drone, and then we can make sure it works well. So some customers only want that modular system. Some customers want the software system. And especially if you're a smaller drone, you're going to deploy it by software system because you don't want to add a bunch of weight. And so one other really cool piece about this is most commercial drones in the US and defense drones use one software stack called the PX4 software stack. We have a ton of experience developing in that software stack. Also, NVIDIA and Qualcomm are the primary chip providers for a bunch of AI systems. Most drones either have a special NVIDIA chip on board to do fancy vision calculations or a Qualcomm chip on board to do vision calculations. So we actually, NVIDIA is one of our partners on our current Air Force contract that we're on, and we're testing our software on these Qualcomm and NVIDIA chips. So we're working a lot on the partner front for future distribution here.
That's super interesting. Might be worth mentioning it.
Yeah, no, we have a whole nother partnership with the future aerial highway management companies, and then we're trying to do things smoothly in 3 minutes. So we really should mention that too.
Yeah, great. Thank you so much, everyone. Round of applause.
Yeah, thank you so much.
Yeah, and I want to thank all of our speakers. Want to thank our judges here.